Namaste. Welcome to PABSON Distance Learning Education Program, collaboration with Janata Television. Today, this grade 10 science that we have discussed previously also, that we have, today is the continue class of the previous class. So this is day 2. So before starting, let's see what we have learned previously. So quick revision of the previous day. So let's start from that. Okay, previously we have discussed the force, definition of force that we have discussed previously, and similarly gravitational force, definition of gravitational force, and Newton's universal law of gravitation that we have discussed in the first class. And similarly we have discussed the mathematical expression for the Newton's universal law of gravitation that we have derived F equals to z m1 m2 by d square. So previously we have derived this also, and also we have discussed about the gravitational constant G, capital G, and its unit and the value also that we have discussed in the first class. And similarly we have discussed the variation of gravitational force with the product of mass and the distance that we have discussed in the first class. So today we will continue this class with the numerical problem of this gravitational force. So let's start with the numerical problem. So you can see on the screen also there is slide that we have taken the one numerical problem that we will start the class with the help of this numerical problem. So the question is like this: calculate the gravitational force, you can see on the screen also, between the sun with the mass 2 into 10 to the power 30 kg and the Jupiter with the mass 1.9 into 10 to the power 27 kg if the distance between them from their center is 76.8 into 10 to the power 7 kilometer. So we need to calculate the gravitational force. So let's start to solve this numerical problem. So solution here. So what is given in a question is mass of sun. So I will represent this m1 is given over there 2 into 10 to the power 2 into 10 to the power 30 kg. This is mass of the sun. Similarly, mass of Jupiter also there, mass of Jupiter. So I will suppose this m2, mass of Jupiter is given over there 1.9 into 10 to the power 27 kg, 27 kg. And distance between them is there, distance between them. So symbol, I will write down this d. So let's write down symbol d. So this is d. Distance is given over there 76.8 into 10 to the power 7 kilometer. 7 kilometer. Distance is given that 76.8 into 10 to the power 7 kilometer. Okay, one more information. So you can see here also G also we have. So let's write down this G also. Gravitational constant. Gravitational constant. Constant. So symbol is capital G. The value we have discussed previously also, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this one is the value of G which we have discussed previously also, right? So this is the given in the question. Now what we have to find here, we have to find gravitational force, capital F equals to what? We need to find this one. Okay, before solving this, we need to remember that all the system of units should be in the SI system of unit before calculation. Otherwise, the calculation will be wrong. That's why let's check either all the units are given in the SI system of unit or not. So mass is given here kg. This is SI system of unit. It's okay. And next one, this mass, another mass also given in the kg. That is also okay. But distance is given in the kilometer. which is not SI system of unit. So we need to change this kilometer into meter. And how we can convert this? So we need to multiply by 1000. That is 76.8 into 10 to the power 7. So instead of this kilometer, multiply by 1000. Now it is meter. Now this is in the SI system of unit. And this gravitational constant we have taken in the SI system of unit. Now we can proceed this numerical problem. So now formula. Now we have, so what is the formula? F equals to Z m1 m2 by d square. This is the formula of the gravitational constant, gravitational force formula. Now let's put the value of this one. This G is there. It is 6.67 into 10 to the power minus 11 is there. This is the value of G. Okay, unit, no need to write down. If you want to write down, no problem, you can write down. But better not to write down. And this M1 is there. M1 is this 2 into 10 to the power 30 kg is there, right? And M2 also there. That is 1.9 into 10 to the power 27 kg. 1.9 into 10 to the power 27 kg is there. So whole divide by distance is given there, 76.8. Now this 10 to the power 7 is there. If we add 3 more 0, then that I will write down 10 to the power 10 to the whole square. So this we have substitute the value from the given. Now let's continue this. Okay, let me write down this again so we can easily visible. So 6.67 into 10 to the power minus 11, right? Into 2 into 10 to the power 30 into 1.9 into 10 to the power 27 is there, divided by, this is 76.8 into 10 to the power 10 to the square. So how we can solve this? There is 2 ways are there for solving this numerical problem. One way is directly you enter this every expressions in the calculator directly. One is that, right? What I mean is this 10 to the power also we will insert on the calculator directly. Another method is this terms. You can see here this one terms, this terms, and this term we will multiply, and remaining this power we will simplify separately. Any method you can use for solving this. So right now I will enter this everything. And one more thing is to enter this 10 to the power, for example 6.67 into 10 to the power minus 11 Newton meter square per kg square. So how to insert this in calculator is, so this is 6.67, and instead of this we will press either EXP in your calculator. That may be either EXP in some calculator, but in maximum calculator you will get this sign. This sign you will get. So for inserting this in the calculator, either we use this if that is available in the calculator, and either we use this EXP if that is present in the calculator. So remember this thing, okay? And for inserting this minus, then there is this kind of tab is there in your calculator. That we will use. If you use minus negative sign, then that may be problem sometimes. That may create the problem sometimes. That's why let's use this tab for inserting this minus 11. So let's check this one. So this one, 6.67. Okay, with the help of calculator, let's do 6.67 into 10 to the power minus 11 into 2 into 10 to the power 30 into and 1.9 into 10 to the power 27 is there. So when we multiply this, then we will get this 2.53 into 10 to the power 47. So after decimal, 2 digit you can take. If you want 3 digit, 4 digit, no problem, but 2 digit is enough. So divided by, here is 76.8 into 10 to the power 10 to the square is there. So it will provide 5.89 into 10 to the power 23 is there. So after simplification, we get this 2.53 into 10 to the power 47 divided by 5.89 into 10 to the power 23. That is the after multiplication, right? So, okay, after this, let's divide this one. This is 2.53 10 to the power 47 divided by 5.89 into 10 to the power 23. So if you divide, then the answer is 4.29 into 10 to the power 23. Now we calculated this force. So what is the unit of force? Definitely that is a Newton. That's why the conclusion, let's write down the conclusion also, so that the numerical problem we can easily understand. Therefore, the force of gravitation between Sun and Jupiter is 4.29 into 10 to the power 23 Newton. So in this way, we can solve the number of numerical problems related to this gravitational force by using this formula. Sometimes the gravitational force may be given and you need to calculate the mass. Sometimes you need to calculate the distance. So according to this formula, we can calculate the force also. Sometimes we can calculate the mass also, and sometimes we can calculate the distance between them also. So let's collect some numerical problem, then you can practice yourself in your home also. Okay, so these are about some numerical problem that is related with this gravitational force. Okay, now next one, let's move on to next one. So you can practice some of the numerical problem yourself also in your home. Let's collect the numerical problem and let's practice yourself. Okay, next one is we have gravity. Also, we can say that is a weight. Gravity or weight. Now, what is gravity or weight? So you can see here, this is spring balance, right? And this spring balance specially used to measure the weight. Right? In general life, we can use this to measure the mass also, but specifically, this one is used to measure the weight of an object, right? Now, if I put some object here, suppose, okay, I'm using some object here, let's say, in this, right now, I'm using my own hand. So if I use some object here, then it shows the reading. Right? Whenever we put the object here, then some force of attraction is there by the earth, which is attracting it towards its center. What I mean is, whenever we put the object here, the earth is there. That earth is attracting this object towards its center. So that force of attractions of the heavenly bodies to the surrounding object towards its center is called the gravity, or simply we can say it as a weight also. Clear? So what is gravity or weight? The gravity or weight is the force of attraction of the heavenly bodies to the surrounding object towards its center. That is called the gravity or weight. Clear? And simply it is the gravitational force. Right? It is a special kind of gravitational force. That's why the unit for this gravity or weight is Newton. Okay? So what is the unit of this gravity? The unit of gravity. Gravity is Newton. Okay, so weight and the gravity, that is a similar things, so the unit of gravity is the Newton. Now it is the special condition of the gravitational force, Newton's universal gravitational force. That's why let's derive for this also. Okay, so let's take one of the object that must be the heavenly bodies. So let's say the earth. So here is earth, right? This one is earth, and one object is there at its surface. Okay, so let's say let the object of mass small m. So I have represented here by the small m. So this one is small m, mass of the object which is found at the surface of the earth, right? And let the object of the mass m is placed at the surface of earth with mass capital M. So remember that generally the mass of the earth is represented by capital M, and the small m is the mass of the small object. That is a general assumption, or a standard also you can say, no problem. Okay, and now look at here, distance between them, this is the radius of earth r, right? And the distance between them, we will consider this r. Why? Because the object is so small, very small the object is, so the radius of that object is negligible in comparison to the radius of the earth. That's why we consider the distance between them the capital R. So if distance between them is r, then we can write down this W. W is the gravity or the weight. It is a special kind of the force, right? So weight will be capital G according to this formula, right? Whatever we have discussed previously, capital G. Instead of M1, we'll write down this capital M because it is a mass of the earth, right? Another M1, M2 is there, that is a small m by r square. So this is the next formula for calculating the weight or the gravity. And I have already said it is a special case of the Newton's universal law of gravitation. So the unit of this weight also the Newton. Unit is Newton. Okay. Now, so let's see here. This weight is there. This capital G is universal constant. Everywhere the value is similar one, right? It is a gravitational constant, so value is constant. So this small object m also, if we take the object in the different places, then this mass also constant, isn't it? Right? Then this weight is proportional with the mass of the heavenly body, right? And inversely proportional with the square of radius. That is square of radius. So weight is directly proportional with the mass of the heavenly body, right? And similarly, the weight or the gravity, that is inversely proportional with the square of radius. Due to this reason, the weight of an object vary from place to place or from different heavenly bodies to another heavenly bodies. Weight is vary. That's why the gravity of moon is 1/6 of the gravity of earth, because the mass is smaller one of the moon, right? Similarly, the gravity of the Jupiter is 2.5 times heavier than the, or greater than the gravity of the earth, because the mass of the Jupiter is 319 times greater than the mass of the earth. That's why the value of gravity is 2.5 more than the gravity of the earth. That is some information about this. Now, due to this gravity, some different effects are there in our daily life or in the earth. Different effects are there due to the gravity. For example, we can easily walk on the road due to the presence of gravity. So sometimes you might have seen the different videos on the moon. The people will feel difficult to walk on the moon because of the less gravity, isn't it? But here we can easily walk. That is due to the presence of gravity, right? And around us in the earth is completely surrounded by the atmosphere. That presence of atmosphere also due to the presence of gravity in the earth. That is a advantage or the effect of the gravity. Similarly, sometimes the tides occur on the ocean. That is also due to the gravity of the moon, right? Similarly, the water flow from the top to bottom or higher altitude to the lower altitude. That is also due to the presence of this gravity, right? And whenever we throw any object in the directly upward direction, then every object that falls towards the center of Earth, that is also due to the presence of the gravity. So there is some effect of gravities are there in our daily life. So that is some effect of the gravity that present in our daily life. So let's solve the one numerical problem related to this one. So you can see on the screen also the numerical problem. The question is there on the screen, so you can see. So let's see. The radius of moon is given 1.7 into 10 to the power 6, right? So I will write down in board also, no problem. So solution here. So radius of, there is given that radius of moon. So radius of moon. So what we are going to do is we are going to calculate the gravity of the moon. Okay, the gravity of moon we are going to calculate. So you can see the question on the screen also. Radius of moon is given there 1.7 into 10 to the power 6. Radius is meter, right? And the mass of the moon also given over there. Mass of moon. That is, so I will write down this capital M. Okay, and there is given 7.2 into 10 to the power 22 kg. This is the mass of the moon. So moon, right? And next one is given over there. What is the gravity of the moon on the body with the mass 1 kg, right? So another mass of object. So I will represent this by small m equals to 1 kg, right? We need to calculate the gravity. So gravity of moon. So whenever we represent this gravity, then we will be confused here. Gravity, it is not small g. It is the W, or force also we can write down, but specific one is the W. So let's not forget this gravity, it is not small g. It is the capital W. So let's not be confused to represent this gravity of the moon. That is the W, right? This we need to calculate. So we have the formula. We have, what is the formula? Weight equals to Z capital M small m by R square. This is the formula to calculate the gravity or the weight. So let's substitute the value of this. So this G, okay, you can write down here the value of G also. That is 6.67 into 10 to the power minus 11. That is the value of G. So you can list out on the given also, no problem. And before that, let's check the unit. That is already in the SI system of units. So there is no problem, right? Into mass of the moon is there. That is 7.2 into 10 to the power 22 kg is there, right? And the mass of the small object, that is 1. Divided by radius is there. That is 1.7 into 10 to the power 6 to the whole square. So let's not forget to square this. Sometimes we may forget to square this. On that condition, the numerical problem may be wrong. So let's be care about this square also, right? So let's simplify this. Let me drop this two more line. Okay, so with the help of calculator, let's calculate. So this is W, right? So here there is given 6.67 10 to the power minus 11 into, this one is there, 7.2 into 10 to the power 22. 7.2 into 10 to the power 22 into 1. That gives the value 4.802 into 10 to the power 12. Okay, so this one is 4.802 into 10 to the power 12 whenever you multiply these numbers, right? Okay, then this one, so divide by, this is 1.7 into 10 to the power 6 to the square. That is 2.89 into 10 to the power 12 is there, right? Square of this one. Now let's divide this. This one is 4.802 10 to the power 12 divided by 2.89 into 10 to the power 12. It gives the value is 1.6615, right? And it is the weight, so the unit of weight is Newton. That's why the gravity exerted on the 1 kg mass in the moon is 1.6615 Newton force is exerted on that object of 1 kg. Okay, so this is the way or method to calculate the gravity of the heavenly body. Okay, so in the same way, let's collect some numerical problem and let's calculate in the same way by using the formula. Okay. Okay, so next one is here, acceleration due to gravity. Okay, next one is acceleration due to gravity. Acceleration due to gravity. So the term itself explains the definition of this one. What I mean is, this is acceleration, right, which is produced by the gravity. What I mean is, when we let to fall the any object from the certain height, then the velocity get increased regularly. That means the accelerations of the object get increased in the time intervals. And acceleration get produced over there. The uniform acceleration get produced due to the increment in the velocity. That's why the acceleration produced in the freely falling object due to the force of gravity is called the acceleration due to gravity. This acceleration due to gravity is produced specially on the freely falling object. Clear? So symbol for this acceleration due to gravity, we will represent this by small g, right? Small g is the symbol for representing the acceleration due to gravity, and the unit is meter per second square. As the acceleration is the velocity per unit time, so the unit is meter per second square. Okay, now the acceleration due to gravity, I have said this g, and we need to derive the formula for this one also. Okay, and before deriving, let's see the value. The value of acceleration due to gravity of Earth is average value is, okay, average is 9.8 meter per second square. So we may calculate this value later on also, how this 9.8 meter per second square. So before that, let's derive the formula for this acceleration due to gravity. Okay, so for this one, okay, language I will not write down. I will simply write down the steps only. Okay, language you can get reference from the other sources also. So here we are going to calculate the value of the formula for the small g. Okay, mathematical expression for small g. Okay, so this one is earth, right? And this is the small object, let's say mass small m, right? We are going to calculate the acceleration due to gravity, this g. So I will write down this quickly, so reference you can get from other one. So we have the formula: weight equals to g m small m by r square. This is equation 1, and this is the weight. So weight can be calculated by the weight equals to mg also, right? This is equation 2. So solve this equation 1 and 2, then we will get this g equals to gm by r square, which is the formula. Okay, so this formula we will derive in detail later on also, right? So today we have discussed this acceleration due to gravity. A numerical problem also we have discussed. So in the next class we will continue the numerical problem related to this also, and some more other content also we'll discuss on the next class. So thank you very much for joining this class. So have a wonderful day ahead. Thank you very much.